Hi, this is Sean Kim. Welcome to Tic Tae Toe in Python. So let's get started. Okay, we're going to run sniffer to run the tests whenever a file changes, and we'll set this up so that we create position. Okay, so first we set up a test for position, and we test the constructor. So we expect that when we call the constructor that the board is set to be will be 9 spaces, and it'll be X's turn. Okay. So the error says that test case is not defined. That's because we need to import that. That's from unit test. Okay. Now it's complaining about position, so we need to import that. And position doesn't exist yet, so we need to create that. So let's create position.py. Alright, so we create a class called position, and it says no attribute board. So let's create the constructor and set the board to be 9 spaces. But let's store it as a list, and it'll be X's turn. So this would be a list of 9 spaces, 9 strings. Okay, this is fine. So next, we're going to create the same constructor test, except it'll take arguments. Okay, and it'll be O's turn, so it'll make it a little bit different. And let's put an X over here. So that would be the board is going to be let's see, let's put that X right. It's in the first position. Okay, and the turn is going to be O. Okay, we get an error saying that it was expecting 1 argument. So now we need to change this so that it takes in a board. By default, it'll be 9 spaces, and the turn is going to be X. So then we just update these. Okay, so now everything passes. So we'll test equality. So if we have the initial position and another initial position, they should be equal. Okay, so before we do that, let's change the representation of what the output looks like, because the output looks like this, and this isn't very helpful. So we'll replace that with something a little bit more helpful. Okay, so it'll return 2 parts. The first part will be okay, so we're going to take the board and join it all together, so it'll become 1 string. And we'll take the turn. All right. So now the error message should look a little bit better. So here we're calling repr on each of those items so we can see it as the string form. Okay, so we can see that they should be equal. So let's go and write the equality. Oh, actually, it takes in the other. So it's the same if the board is the same and that the turn is the same. Okay, got that passed. Next is move. So if we have a position and we make a move on 1, then it should look like let's see, it should look like this with X in the 1 position. This is 0, so this is 1, and it should be O's turn. All right, so let's create move, and it takes an index, so return self. So it returns a, okay, okay, we have too many parentheses. Okay, so we can see that we need to update the board because it expects an X over here, and the turn should be changed. So the board's position will replace that with the whoever's turn it is, and the turn we're going to, if it's X's turn, we're going to return O, otherwise X. And we don't have choose yet, so we'll just create choose, the X value and the O value. So if return X if turn is X, else O. This is Python's way of doing a ternary operator. Okay, good. Next is possible moves. So if we start off with the initial position, make a move, possible moves of that would be 0, 2, 3, 4, 5, 6, 7, 8. Okay. Possible moves. So we start off with a list. Well, let's just start off with an empty list just to get started. Okay, so we'll make a list comprehension that returns the indexes. And the indexes we'll start off with, okay, we need an index and a piece. And we are getting that from the board. Okay. So, if we just say board like this, then it won't work. We need to say enumerate. That's so that for each element of the board, it'll return tuple with the first element being the index, and that is what we want. Okay, and the test that we're using is that the piece is a space. So this is all the index position of the spaces. Okay, and that passes. So far, so good. Next, we're going to create a new class, test class for isWin4. And the reason why is because we have multiple tests for these. So it's better to branch off to another test. So let's see. X wins. Actually, let's start off with no win. So if we have, actually, it returns true or false. So instead of using assert equal, let's return assert true or assert false. So this will be assert false. We start off with an empty position, the initial position, and we say is win for X, and this should be false because it's not. And we'll just set this up. So is win for, and we have the turn. So we'll just return false for now. Okay. All right. So the second test case is if X wins. So actually, X wins on the row. So let's set it up. Actually, this should be assert true. Okay. So we set up a position where where X wins. So okay, so that should win. Okay, assert true. Okay, we didn't call is win for. Okay, that's why you should always start with a failing test. Okay, so all right, so now let's make that happen. So okay, so let's create a lambda expression. So is match, because this will be very useful. So that's a lambda which takes a line. I say a line instead of a row because row means going across, but a line could be in any direction. So we take account of the piece that we're looking at, and actually in this case it's probably better to say piece. Oops. Okay, so is win for piece. Okay, so if the count is 3, we have some magic numbers here, and we could just, we'll just keep the magic numbers for now. Okay, so yeah, we'll just get rid of it. So this is our dimension. So we can say dimension is 3, and size is dimension times dimension. So this way, it's usually a good idea to get rid of magic numbers. So this way, when you see a number, it has some meaning. So we know that this has a meaning, which is the dimension. Okay. All right. So we start off with that, and let's see. We want to check the rows. So first, we need to take the board and split it up. So okay. So if we have an index that goes from let's see, that goes from 0 through the size, but in steps of the dimension, then what x is the first position of each row. Okay, so if we have the first position of each row, then we want that list, this sublist, to be up to that dimension. Okay, and we put this in a list comprehension, so we just put some brackets around this, and this would represent the list of rows. But what we want isn't the row. For each of the row, we want to run isMatch on it. So this will be a list of booleans. So it'll say true, true, false, or false, false, false. Okay, and we'll return if any of the rows is true. Okay, so that passes. So now we need to do the same thing for the column. So we start off with the position with, and we say is win for, this time let's choose O just to make sure that it handles both X's and O's. So let's see, 1, 2, 3. Okay, so this is the first position of each row. So it's the first column. So now we do the same thing, calls, except that now the range is going to go from 0 through the dimension. So it'll be 0, 1, 2. So it's the topmost column. And if we want to go down, we start with the I, and it'll go to the size all the way to the end, but in steps of the dimension. So this way it gets each of those column elements and run it through isMatch. So now we can say or any calls. Okay, all right, so that passed. And then the next is major diagonal. Okay, so we have, let's just do X again. Oh, need the parentheses. Okay, so the major diagonal is here, 2, 3, X, 1, 2, 3. Actually, let's see if I have this right. So X, 1, 2, 3, X, 1, 2, 3. Okay, so we have that. Okay, so now for the major diagonal, so major diagonal. Okay, so we need to get the board starting from 0 and all the way to the end. But in steps of dimension +1, so this way it goes diagonally. And we need to close the parentheses. All right. Actually, we need to say major diagonal, like here. Okay, that passes. And we also need to do the minor diagonal. Okay, so that would be is win for X. Okay. All right, so that would start from the end position, the middle, and the first position of the last row. Okay, so the minor diagonal starts from dimension -1. If we did dimension, that would just be the second row, but if you do -1, that's the last column of the first row. And we're not going to include the end, its size -1 and steps of dimension -1. And this is because if you have this, so you can see that it starts from here and we increment by 2. And if you increment by 2 again, then it's here. And if we increment by 2, we'll also have this. But we don't want to include this. So that's why we're doing size -1. All right. And now we just add this to minor diagonal. Oops, missing something. Oh, just missing parentheses there. Okay. All right, so everything passes, and we're off to the next part. So we need Minimax now. Okay, so the test is we start off with X wins. So okay, so when X wins, we start off with a position, and that should be 6. So let's set up the position. So the position is just XXX, and it's returning 6 because it'll return the number of possible moves, so the blank spaces. Okay, so oh, we forgot to say dot Minimax. Okay. All right, so no attribute Minimax, so we need to create that. So def Minimax. All right, so we know that if it's a win for X, return how many spaces there are. Okay, so that's good. And O wins. And that should be -6 because for O, it'll go towards the negative and X goes towards the positive, so they try to fight for their space. Okay, so we need to say if is win for O, then return how many, but we need to return negative. Okay, then we need to test for a draw. So let's see. Okay, so let me just fill in the rest of these. Minimax, and that should be a 0. All right, so it'll look like XOX, XOX, OXO. Okay, so that should be a draw. So if board count of spaces is equal to 0, then just return 0. All right. All right, now we have to handle the recursive case. So what happens if X wins in one move? So we set up a position, and that should be still 6. All right. All right, so let's handle that case. So we start off with the list of possible moves. Okay, and we want to put this in a list comprehension. So we run through each of these. So for index in this. And what are we going to do? We're going to run. Okay, we start off with the self and make a move, make that move. Then we're going to do Minimax on it. Okay, so that should return a list of Minimax values. But there's a problem with this. The problem is that move is destructive, that it actually changes the state of the state, so of itself. So the first time through, it'll make the move, but the second time through, instead of starting with the original position, it's actually the modified position. So we have to make a copy of this. So let's use deep copy of the self. All right, and that should give us a list of minimax values. So values, okay, and the value that we want is the max of values, and we'll just return that. Okay, so let's import from copy, import deep copy. All right, so everything works. All right, so okay, so now we need to do the same thing for O. So we'll just change this to an O and change that to an O. We have to be careful here because by default it was X's turn. So we need, but this time we need to say specify that it's O's turn, and it should be a -6. Okay. All right. So the reason why this didn't work is because it's always trying to find the max. So depending on whose turn it is, so I'll use choose this time. So choose and run max if it's X, otherwise run min. Okay, so this is complete, except that let's test the initial position. We call Minimax on it. Now this is going to take a very long time. I just saved. Oh, actually, I just saved right now. It started off, and now it's going to take a very long time. And there's a lot of redundant calculations that it's doing. So we can save some time by creating a cache. So we'll initialize the cache as empty. And in the beginning, we need a key first. So the key is going to be the representation of the self, the position. So that took about close to 26 seconds. All right. So given the key, we're going to say cache key, and that will give us the value. And if the value is not none, then return value. Okay. All right. So we have, okay, so cache. Okay. So let's okay, well, we also need to store the cache once we found a value. So cache key is equal to value. So this is one step that we forgot. Okay, so we're getting key error here because when we index it like this, it'll throw an error if that key doesn't exist, and initially we start with an empty dictionary. So of course we're going to get a key error. So instead we're going to use get. Okay, so this way if it's not found, then it'll return none. Okay, this took less than a second. Okay, so that's really good. One note of caution about using of writing this part of the code is that it's tempting to say if the value exists, return value. But there's a problem with this. The problem is, let's run this, and you can see that it's taken a bit of time. It's about 3 seconds. The reason why is because if the value happens to be 0, then 0 is considered false. So so then it'll think that it doesn't exist, and it'll continue on, and it'll always recalculate the draw positions. So you have to compare it with none. Okay, so now we put it back, and again it's fast again. Okay, so next we're done with this now, so we need to find the best move. Best move. Right. So let's see. So test for X. Okay. So we start off with a position, and let's explicitly say it's X's turn, and we say best move, and let's let it be 2. So we'll set this up. So it'll be XX, and we leave it blank. So it's X's turn, and the best move is to complete the wind, which is right here on position 2. Okay, so let's write best move. Okay, and the way that best move would work is it would use I'm just going to copy that part of it, and okay, so this gives us a list of Minimax positions, but what we're going to do is we're going to start off with we're going to call max based on the list of possible moves. So we want to find the best possible moves, but using a certain criteria. And the criteria that we're going to use, and we're going to create a lambda here, given the index. And so the criteria that we're going to use is this, a deep copy move minimax, so the minimax value of it. Okay, so we'll find the max based on this criteria, and so that should be it. Oh, I forgot to say return. Okay. Okay, so it passed. All right, so next we can't forget to do the same thing for O. Okay, and also the best move is 2. Okay, so let's create a function here so that it chooses max if it's X's turn and min if it's O's turn. So we'll just call fn over here. Okay, so everything passes, and the logic of the program is complete, except that we need one more thing, which is game end. Okay, so let's see. Not end. Okay, so if we start off with, okay, so we assert false. If we start off with the initial position and we call isGameEnd, okay, okay, we'll write all the tests because it's really pretty straightforward here. Test X wins. So when X wins, this will be true. Okay, so we'll set it up so that X wins here, and O wins. Oops. And this just, oops. Okay, trying to do something a little tricky here. Replace X with O. Okay. All right, so we have 3 failures. Oh, actually, there's one more condition. Draw. Assert true, position is game end. Okay. And we'll have XOX, XOX, OXO. Okay. All right, so these are the 4 conditions that we need, and we can make this pass pretty easily. So first, we need to have test draw. Not test draw. Let me see, is game end. Okay. Oops. Extra parentheses there. So if is win for X, or is win for O, or the board count if the possible moves is 0. Okay. All right. Let's see. All right. So this is good. All right. So now we're going to start off with the game. And okay, test case. And we'll start off with the setup, because we're going to refer to the game. So self game, we'll create a new game, and we'll test the constructor. So okay, so when you have a game, we expect that it has a position, and that position is the initial position. Okay. there's a little bit of a lag here because it's running the other test as well. So what I'm going to do is I'm going to say just run the game. Okay, so now it's a little bit faster. Okay, so it says test case is not defined, so that means we need to from unit test import test case. Next. Okay, game is not defined. From game import game. Okay, doesn't know about game. So we create game.py, create a class called game. Okay, it has no attribute position, so we'll create it. So position is the initial position. All right, position is not defined. From position import position. Okay, over here too. So from position import position. All right, so everything passes, so we're set up. All right, so the first thing we're going to test is ask for player, and this is based off of game. So this is a derived class. So this way we have the setup. Okay, so we're going to test for quit. So if we start off, okay, so with mock input. So when it asks for the input, we're going to provide the return value. So this way it doesn't prompt us for it. So what we're doing is, so if I say raw input stored into X, say name, it'll ask us for our name, and then if we check the value, the variable, we notice that it has it. But we don't want to have our test prompt us every time. So instead, we're going to mock it. So anytime that it calls raw input, it'll return whatever we provided. Okay, so let's go back. And that's what we're going to do. We're going to have a mock input, and we're going to define this later, of Q. And we'll say ask for player, and it should be none. Okay, and it doesn't know about mock input, so let's create that. So okay, so we're going to use patch. And raw input is part of built-in. This is the module, and it's raw input. And we're going to have a side effect here. And we pass it the list of arguments. So this is a list of arguments. And so the first time it's called, it'll pop off the first element. The next time it's called is going to pop off the second element, and so on. And we need to import patch. So import it's from mock, so import patch. Oh, we've got to return it. Okay, otherwise it'll just return none. All right. So it doesn't have ask for player, so let's just ask for player. All right, passes. So now we choose the computer. Okay, so with mock input, we're going to choose 1, and 1 is going to be the computer. So it'll end up being game computer. Okay, so there's no computer, so we'll just add computer to here. We'll just some value. Okay, so it's expecting it to return a number. Okay, so so raw input. Who goes first? 1 is the computer, and 2 is you. and we'll put a colon here so we have a prompt, and we store the answer. So if the answer is 1, then we're just going to return game computer. All right, so far so good. Next is choose human. Just put a little character return there. Okay, so it'll be the same thing, except that we're going to change this to be 2 and change this to be human. Okay, so it doesn't know about human. Oops. All right, and we also have to say all right, so that passes. And we also have to check for bad input. So if I start off with X and then return 2, then that should just return human. Okay, so it got none. So we're going to make this loop. So while true, we do this and say if answer is Q, return none. So if you quit. This is to make sure that this test passes. And it'll keep repeating until you get a valid response. Okay, that's good. All right, so we're done with ask for player. And actually, well, we'll just do this for now. Okay. Not this one, the class. Okay, so we're going to test ask for move. Okay. Good test for the quit. So it'll be the same thing with mock input. We're just going to quit. And when we quit the ask for move, it'll just return none. Okay, so let's see. And it says we need to have, let's see, ask for move. Okay, we'll just say pass for now. Okay, that's good. And next is we're going to choose an empty square. Okay, so maybe we can save a valid move. Okay. With mock input, we'll just choose 1. Okay, so initially the position is empty, so any number should work. Any number between 0 and 8. Okay, if we ask for move, that should return us 1. Okay, so it returned none. So so we ask the user for the move. Okay, so this is our prompt. And okay, if it matches the regular expression, which is starts with a digit, and actually it's just a we'll just do this, all digits. Okay, up to the end. If the answer matches that regular expression, then just, oh, actually there is another condition here, which is actually we should have the index here. It converts that to an integer. And then we also do another test. So if we go to the game, the position, the board, if that is an empty square, then we're going to return the index. Okay, that looks good. Okay, so RE is not the regular expression we need to import. Okay, there's no attribute game. Oh, we're inside of game already, so we don't need that. Okay, all right, passes. So now let's check an invalid move. Invalid, actually, there are different kinds of invalid moves. So out of bounds. Okay, so we'll start off with 9. So 9 is out of bounds, but then we'll give it a valid number. So when we ask for move, that should return us a 2. It'll skip the 9. Okay, index out of range. So we'll put another check in here saying that if index is between, let's see, dimension. Okay. Oh, is between this. I think we also have to import a dimension as well. So actually not dimension, it's the size. Okay. So this is it's returning none, and the reason why is because once it has the invalid input, it needs to ask it again. So we need to put this into a loop. So while true. All right. This is a stop iteration, which meant that it ran out of inputs. So it kept on going. So when it received the 9, it probably went through, and then when it received the 2, it should have passed. So let's see what happened. Okay, so let's just print out the index. Okay, let's just print out the answer. So repr of answer. Okay. Oh, for the Q. Okay, so we have to put a test here. If answer is equal to quit, then return none. Okay, so we need to make sure that that's handled. Okay, so far so good. The other kind of invalid input is bad input. Let's see. Oh, actually occupied. So we went a little bit ahead of ourselves by already checking the occupied square, whether or not it's occupied. But we'll add that test anyway. So we're going to choose 1 and then choose 2. So first, okay. Actually, I'm going to pretend that I forgot to write this. So this way we can start off with a failing test. See, even if I commented, took that part out, it still passed because we didn't write a test for it. So this is a test that tests for that part. All right, so position, we make a move on 1. So now when we do ask for move, it should return 2. So now we have a failure. So now we can get rid of this and uncomment that to introduce the new code. Now it passes. Okay, so what about bad input? This is something that is not a number. So with mock input, if I put an X and then a 2, then that should be a 2. Okay, so that handles bad input. Okay, this isn't a failing test, but I see that it's all running because it's inside of a loop. All right, at least it didn't crash. All right, so now we can try a complete game. So let's try a play. Actually, we need, it's part of test game. All right. So we have the, okay, so let's just play. Okay, so with mock input, let's just see what happens if we press a Q. Actually, let's just do it incrementally, so quit. So if I just press Q, then what will happen when we play is that it'll return none. And the return value of play is who won. So whether it's the computer or the human, or it's a draw. None means that we just quit, so we don't know. So let's see. No play. Play. Okay. So it passes. Okay, so let's make a move. Okay, so actually let's okay, so okay, I think we can, no, let's choose a player. So choose human. So with mock input. So the first thing it should ask us is whose turn it is, and we'll just say 2, which is human. Okay, yeah, should try to be consistent. Okay, with the quotes. Okay, and now it should say game human. All right, received none. So we should ask ask for player. Okay, and oh, it's part of this. Okay, and it's still returning none because we need to let's see. Oh, actually, this is incorrect because this should tell us not whose turn it is who won. So we need to quit after this. So this should still be none. Okay. And the next step after choosing a human is making a move. So we'll just say move with mock input. We choose, we'll go first, then we'll choose 1. So when that happens, and then we'll quit. So when that happens, well, actually, there is a test here that we forgot to put, which is there's a player, and that player should be human because we chose it. And all right. Okay, so start equal first. We'll play, and this should still return none because we quit before the game was over. And at this point, we still want to test the player, and then we want to check the position. Okay, and we made a move on 1, so the 1 position should now have an X in there. Okay. Okay, so we need to make the move. So we make the move by we need the index. So okay, so ask for move. Okay, we have the index and then we make the move. So okay, list indices must be integers, not none type. Okay, the reason why this happened is because let's see. Oh wait, let's see where this is. Okay. Okay, so there's a stop iteration over here, which means that it ran out of moves. It ran out of input, and the reason why is because it's not because of this test. It's because of the previous test. Choose human. So when so when we chose a human, 2, and then we quit, so the index will be none. But then we try to call none. This is the same thing as saying self position move none, and that doesn't make any sense. So we have to put in a test for that. So if idx is equal to none, then return none. Okay, so this means that the player aborted the game. Okay, now we have a stop iteration here for test quit, and the reason why is the same thing. So if they initially just press quit, there is no player, so we can't continue on. So we need to say if player is none, return none. Okay. All right. So far so good. All right. So now we can play a full game. Complete game. Okay. So I'm gonna play and see if I'm gonna let the computer win. Test computer win. That's probably a better title. Okay, computer win. Okay, so I'll go first. Okay, I'm just gonna put a quit in here. Actually, I'm just going to not put a quit in there. Okay, and let's see what happens. So I expect that after this game is complete, the computer will win. So I'll just say computer. All right. So we have a stop iteration, which meant that the game was still asking for input, but we ran out of input. And what would be nice is if there was some print statements that would show us what our situation is. And we can do that because when we're asking for a move, it doesn't print out the prompt, but it will print out if we say, for example, print game position. And let's see. A game is not defined because we're already in a game, so it's just self position. Okay, so it prints out the position, but it's in this form. So let's go back to position py, go all the way to the top, and create the string representation. Okay, so all right, so let's see what we want to. Okay, let's start with the board. Okay, we want to break this up into chunks of rows, and we've done that before by saying I and I plus dim for I in X range, and this is going from the beginning to the end in steps of dimension, so it's always going down 1. Okay, and this is this will return us a list. So this is actually this will return us a list of a list. So I want to join this. The row is going to be joined by a vertical bar. And then, okay, so now I make this into a list comprehension. So now this is a list of strings. And I'll just say join on, well, let's just join it and see what happens. Okay, so we're printing it out, but it prints it out like this. So now we need to join each of those rows with carriage return, and some stuff in between. Okay, yeah, I think I got the right amount of dashes. All right, so all right, so far so good. Let's bring it back. Okay, so mock input. So we have actually, let's have another print here so we have an extra space so it'd be a little bit easier to read. So mock input 2, and let's see. All right, so this is printing the position before they made a move, and let's see. Let's print the position after it makes a move. Okay, so at the very end we'll, okay, so it actually never got to this print because there was a stop iteration because of the 2. Okay, which is what we expected. Okay, so let's continue on. So let's make a move. So let's put in the 1 position. So it should be in top middle. Okay, so okay, there it is, top middle. And but we're expecting the computer to make a move. So the computer, now it's the computer's turn. So we need to put this into a loop. So okay, it asks for a player, that's fine. And while position is game. Okay, so we need to say while the game is still going on, we're going to do this. Actually, this only happens if it's the player. Player is human. Okay. Okay, if the player is human, then we do this. And then we also, actually, we don't want to include this print statement. This print statement would be outside of the while loop, so at the very end, when the game has finished. Okay, so we make the move, but we also have to change the player, so it will be the computer's turn next. Okay, and put an else here, else if. Okay, now if it's the computer, we expect that the we're going to print out the position, and then we are going to find the best move. So okay, so we can say position best move. Okay, and then we make the move. So position move IDX. Okay. All right. Actually, with this, we could probably do it in 1 step. We need to do 2 steps over here because we need to test for none. But we know that if it's the computer's turn, yeah, so we could have just said this. Okay, just make the best move, and then switch the player to be the human. Okay. All right, so now it's going to alternate between the human and the computer. So it's going to go back and forth until the game ends. And then when it does end, it's just going to print the final position. Okay, position is not defined. Print self position. Okay, position, there's another position somewhere. Okay, so let's see where. Okay, global name position is not defined. It's in line 31. Okay, so so self position. All right, and there's a stop iteration, which is what we expect because we didn't do a complete game. So we can see that the computer has made a move. Oh, all right. Let's continue on. So let's choose the. We're going to let the computer win. So I'm going to choose square 2. Okay, that's good. And I'm going to choose the middle square and let the computer win. So the middle square should be 4. All right, so it failed. It ended, but there was no return value. If we take a look here, the assertion, it returned none because we weren't returning anything. So we need to return who won. So now we need to have this condition, which is if we know if it's a win for X, then something, but we don't know what that looks like. Okay, let's print out the final position and then figure out what to return. So who is X? So when it first starts off, we should keep a track. So we have the player's dictionary. Okay, so if so X. Okay, so who is X? Who's the first player? That would be player. Okay, so who is O? Well, that would be the other player. So that would be if, so self, no, it would be game.computer if self.player is human. Actually, let's just reverse this. No, it's okay, human. Okay, game not human. So if the first player is a human, then the second player is the computer. And then we have an else here, so that would be human. Okay, so now we have the dictionary. Okay. All right. So we have X and O. And then we just say return player dictionary of X. So if it's a win for X, then it's that player. Okay, but the computer's O, so we need to do the same thing here. Okay, so everything passed. So now let's do the same thing, same test, but it's a draw. So test draw. All right. So okay, I'll leave everything the same, and I'll just say draw. Okay. All right, so we have a stop iteration because we're not complete. Let's continue the game from here. So I'm going to choose the best square I can, which is the middle. Oops. Okay, and now I'm going to choose a corner square, which is 6. And now this looks like a complete draw. And the next is 3. And finally, I choose 8. Okay. Let's see, at the very top, it says game has no attribute draw. So at least it got to that point. So now if position, well, actually at this point we know the person did not quit. Let's see. So we know it's a draw, so we'll just say return game draw. But we didn't define what draw is, so we'll just go to the top and just add that. Draw is 2. Okay, so everything passes, and we're pretty much done with the test, and we just need to just make the game. All right, so let's just get out of this, and all right. So I'm going to go to the very bottom. So say if the name is main. Oh, the reason why I'm doing it this way is because if I run sniffer now on the whole test, everything still passes. So I want this code to only be run if I run it directly. If I import it as a library, I don't want this code to be run. Okay, so okay, like for example, I'll just print hello here. So you can see that it didn't print hello because it's not, the name is not main. But if I stop it now and I try to run this game.py, it says hello because it'll run. All right. So let's think about this. So we create the game, and then we say game.play, and it'll return if let's just say winner. Okay, if winner is game.computer, then we want to print computer 1. If winner, actually there's 2 equals there. Oops. Is the human, print U1. But I'm going to put a note here saying that this should not happen. Okay, because the computer is playing a perfect game. If winner is a draw, then print draw. Okay. If winner is none, that means you quit prematurely, so we'll just say bye. Okay, so that should be it. Oh, I forgot the colon here. Okay, so let's run this. All right, so make the font a little bit bigger, and Python game. Who goes first? Let's see. I'll go first. Okay, so I'm gonna choose 1, and then so I'm X, and I'm gonna choose the corner, so 2, and oh, I gotta block that. So that's a 6, and I gotta block that, and that is an 8. Oh, the computer won. I wasn't trying to make the computer win, but I got caught in a little trap there. Okay, so let's play a game, and let's see if I can do a draw. So this time I let the computer go first. Okay, and let's pick 0, and it's asking me for the move again because that was an invalid response. All right, so I'm gonna try to make this a draw. So let's try to center, and then block that by going to 2, block that by going to 3, and now it's a draw. So there you have it. This has been Tic Tae Toe in Python.